Hello everyone. The topic that we will be discussing is on electric field and electric field strength. Suppose we have a charge Q, or we can say a source charge, and around this charge, if we bring another test charge, say Q naught, what will happen? It will experience an electrostatic force of interaction. So this region around this charge or a source charge is called an electric field. So what is an electric field? A region of space around a charge or a system of charge in which another charge particles experience electrostatic force is called an electric field. So now let us find what is the expression of the electric field, say at this point. Okay, the electric field at this point is the force acting per unit positive test charge placed at that point. Okay, this charge will experience a force, and the force acting per unit test charge is nothing but the electric field strength at that point. So it is denoted by a symbol E. Okay, so clearly from here the SI unit of electric field strength is Newton per Coulomb. Okay, remember this Q naught must be infinitely small. Q naught must be infinitely small. Why? If this test charge Q naught is not vanishingly small, then the electric field to be measured may be changed by the test charge. Okay, so that's why Q naught must be infinitely small. Strength at a point due to a point charge Q. So let us consider a point charge Q, say this positive, in such a way that this one is X, this one is Y, and this one is Z. Then this is a point P, and we want to calculate the electric field strength at this point. So now let's join this point, this origin O to a point P by R. So we can mark this one as position vector R. Suppose we bring a test charge Q naught at a point. So now, what is the electrostatic force of interaction between these two charges? So F can be written as 1 by 4 pi epsilon naught Q naught by R square. Okay. So this is the force of interaction between these two charges. So if we take this Q naught to the side, we'll have F by Q naught is equal 1 by 4 pi epsilon naught Q divided by R square R cap. So what is F by Q naught? Force per unit test charge is nothing but electric field. So this is 1 by 4 pi epsilon naught Q divided by R square R. So in magnitude, in magnitude, E is 1 by 4 pi epsilon naught Q divided by R square. So the electric field strength at a point which is at a distance R from a point charge Q is 1 by 4 pi epsilon naught Q divided by R square. So one should be noted. So note, number one should be noted that if we have a charge plus Q, the electric field lines of force, they are readily outward. And if the charge is minus Q, the electric field lines of force are readily inward. Okay. Now, having an idea of electric field due to a point charge, then we will calculate electric field at any point on the axial line of an electric dipole. So now we will calculate the electric field at any point on the axial line of an electric dipole. So before we begin with this, let us understand what is a dipole. Suppose this one is a charge minus Q, this one is a charge plus Q, separated by a distance of length 2L. This constitutes a dipole. So what is a dipole? A pairs of equal and opposite charge separated by a small distance is called a dipole. And then we come to another definition, dipole moment. What is a dipole moment? A dipole moment is the product of the magnitude of any one of the charge with the distance between them. It is denoted by symbol P, and this one is equivalent to Q multiplied by 2L. And remember, this dipole moment is a vector quantity and it is directed from minus Q to plus Q. So having an idea of a dipole, so now let us calculate the electric field at any point on the axial line of an electric dipole. So let us consider a dipole of length 2L. So somewhere here, this is the point. Okay, this point, it is located on the axial line. Let the distance of a point P from the center of a dipole, it is R. So if we mark this one by A and this point by B, so the distance from a point B to a point P, it is R minus L. Because from here to here it is L, from here to here it is L. So from O to P it is R, from B to P it must be R minus L. And the distance from a charge minus Q to a point P will be R plus L. From O to P it's R. From O to A it is L. So that's why R minus L. So if E1 is the electric field at P due to minus Q at A, and E2 is the electric field at P due to plus Q at B, then what is E1? E1, the magnitude of the electric field, E1 is 1 by 4 pi epsilon naught. Then the charge, it is Q. What is the distance of this minus Q to a point P? It is R plus L. In which direction? As I have mentioned earlier, that the direction of the electric field, it is toward the negative for negative charge, and away if it is a positive charge. So this one is negative charge. So the direction of electric field, it is from P to A. So the direction of this is along PA. That is direction of E1. And what about E2? This E2 is 1 by 4 pi epsilon naught. The magnitude of the charge is Q. And what's distance from plus Q to P? This one is R minus L. Remember, here it is square, here it is also square. Okay. So now, net field at P. So here, in which direction? E2, the charge Q at B is positive. So the electric field, they are coming out from this plus Q. So this is, the direction is along BP. Okay. So as we have noticed from here, the electric field E1, it is in this direction. And the electric field E2, it is in this direction. Okay. They are opposite to one another. So therefore, the net field at P is E equal E2 minus E1. Why E2 minus E1? Because E2 is greater than E1. E2 is greater than E1. So therefore, where's the direction of the net electric field? The direction of the net electric field is along which direction? It is along BP. So that is direction of E. So hence the net field, it is also in this direction. Okay. So from here, we can write E is equal. Instead of E2, I'll substitute by this. Instead of E1, I'll substitute by this. I can take common Q by 4 pi epsilon naught. Then 1 by R minus L holding square minus 1 by R plus L holding square. So on solving this, we will have 1 by 4 pi epsilon naught. Then the LCM here will get R square minus L square holding square. If we cross multiply this one, we'll have R square plus L square plus 2RL. Then minus, for this, R square plus L square minus 2RL. So this R square go, L square will go, and we will have Q by 4 pi epsilon naught. Then instead of 2RL, we'll have 4RL. So instead of 4RL, I can write 2R into 2L divided by R square minus L square holding square. So this is equivalent. So E is equivalent to 1 by 4 pi epsilon naught instead of Q into 2L, I can put by P. So that is P. Then here, I can write R square minus L square holding square. So this is the magnitude of the electric field at a point P on the axial line. So in vector form, so what is the electric field in vector form? E can be written as 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, then 2 R P divided by R square minus L square holding square, and P in vector form. So this is the vector representation of electric field at a point P on the axial line. Why we can write P vector? Here, because the electric field, it is in this direction and the dipole moment is also in this direction. So since electric field and dipole moment, they are in the same direction, we can write like this. Now special case for short dipole, R square minus L square, it is approximately equal to R square. So therefore, instead of R square minus L square, if we put by simply R square, then we'll have here R to the power 4. That R to the power 4, one R will get cancelled with this R. So what is the electric field? Electric field is equal 1 by 4 pi epsilon naught, then 2R, no, not 2R, 2P. This one R will get cancelled and we'll have R to the power 3. So from here, we can say that, from this equation, we can say that E is inversely proportional to R cube. Okay, so this E is 1 by 4 pi epsilon naught 2P divided by R cube. So from this equation, we can say that E is inversely proportional to R cube. Now, we will do electric field. Electric field at any point on the equatorial line of an electric dipole. Electric field at any point on the equatorial line of an electric dipole. So let us consider this one is a dipole and the length of this dipole is 2L. So somewhere here it is the center of a dipole. From here to here it is L. From here to here it is also L. So somewhere here is a point P on the equatorial line. Okay, so a line which passes to this center of dipole and perpendicular to the axial line is called equatorial line. So therefore, this point P, it is somewhere at this point P is on the equatorial line. Suppose this point is at a distance r from the center of a dipole. Suppose this one is A, this one is B. Join this line. Okay, and mark this angle by theta, and this angle is also by theta. Now, what is the length BP? If you apply Pythagoras theorem, in this right angle triangle POB, this length BP is nothing but R square plus L square. And here, similarly for AP, it will be R square plus L square. Okay? So now, the electric field at the point P is this one. Say, this one is E1. Electric field at a point P due to plus Q is in this direction. And the electric field at the point P, due to minus Q, it is in this direction, E2. Okay, E1 is due to plus Q, and this E2 is due to minus Q. We have learned earlier that the electric field lines of force, they are away from positive, and they are towards the charge in case of negative. So where is the net field? The net field is in this direction. So that is the net field. And I will mark the net field by E. So this one, say it is C. If this one is theta, what is this angle? This will also be theta. If this one is theta, what is this angle? This one is theta. Okay. So now we can resolve E1 along PC. We have learned earlier that if this one is X and this one is Y, and if this one is a vector R, and if this one is theta, if I drop a perpendicular somewhere like this, so I can write cos theta is equal X by R. So what is X? X is R cos theta. So similarly here, what is the components of E1 along PC? It will be E1 cos theta. What is the components of E2 along PC? It will be E2 cos theta. So E1 cos theta and E2 cos theta, they are in this direction. So therefore, net field at P is E, which is equal to what? E1 cos theta plus, so net field at P is E equal E1 cos theta plus E2 cos theta. So what is the magnitude of E1? E1 is 1 by 4 pi epsilon naught. So what is the magnitude? The charge is Q, the distance is root over R square plus L square holding square. And then what is E2? E2 is 1 by 4 pi epsilon naught. So Q, then root over R square plus L square holding square. As we can see from here, E1 and E2, they are equal in magnitude. So therefore, this electric field can be written as twice of E1 cos theta. So what is E1? This is 1 by 4 pi epsilon naught. Then Q. Then if I square the root, so it will be R square plus L square. But what is cos theta from this figure? It is base divided by hypotenuse. What is base? Base, it is L. Hypotenuse, it is R square plus L square. We have to root. Instead of root, I'll put by half. So now, this one become 2L into Q. So 1 by 4 pi epsilon naught. Then P, 2LQ, it is dipole moment. So here, R square plus L square, multiply by this. Okay. Suppose if you have two quantity of the same base, A to the power B, A to the power C. What should we do? A, B plus C. So the power will add up. So here, the power is 1. Here, the power is half. So we can write R square plus L square to the power 3 by 2. So this is the magnitude of the electric field at a point P on the equatorial line. So in vector form, so what is E? E is equal to 1 by 4 pi epsilon naught. Then P vector divide by R square plus L square to the power 3 by 2. I have to put here minus sign. The question arises why? Because the electric field is along PC. But the dipole moment is from minus Q to plus Q. That's why I have to put a negative sign. The negative sign indicates the electric field and the dipole moment. In this case, they are opposite in direction. Okay? So this is the representation of electric field in vector form. Okay? Next, special case. special case. For short, dipole. R square plus L square is approximately equal to R square. So therefore here, what is the electric field from here? 1 by 4 pi epsilon naught. Then P, R square plus L square, we can write as R square, okay? Then 3 by 2. This 2 will get cancelled. So we'll have 1 by 4 pi epsilon naught. So E is equal 1 by 4 pi epsilon naught P divided by R cube. Okay, P divided by R cube. So from here, we can say that the electric field is inversely proportional to R cube.